Hey, welcome back to Mr. PL's with PreCal. This is Unit 1, Topic 1, Lesson 2, which we're going to be talking about domain and range. And starting off with a warm-up on finding the following characteristics, which we did in the last video, a cubic root. Now, keep in mind a cubic root function, you need to know what it looks like. So cubic root looks kind of like this. So it looks like a square root, only it goes on both sides. So it has a domain that goes left and right infinitely, all real numbers. Its range also goes up and down infinitely. It's not bounded on either side. So it's increasing the entire time. So it's increasing from negative infinity towards positive infinity. It's never decreasing. It's symmetrical, which its symmetry is an odd function because it's a reflection over the origin. It has no maximum or minimum, so it goes up towards infinity and down towards infinity. It's not bound at all. So logarithmic functions, if you remember, they look sort of like this, and they have a vertical asymptote. So in this case, the domain would be from, so we're just talking about basic parent function. So the domain would be from everything from 0 towards infinity. The range is infinite, so it goes up and down infinitely. Remember, it does not ever hit 0, which is the reason why I used an open parenthesis and not a bracket, so it's not included. So it's bounded. There is no bounded because it goes up and down infinitely. So it's increasing the entire time from 0 towards positive infinity. It's never decreasing. It's symmetrical is neither. It's not odd functions, nor it's an even function. It does not have a maximum or a minimum. So absolute value is when the function looks like this. Its domain is all real numbers. Its range starts at 0, which is included, and it goes towards positive infinity. You can't include infinity, though. It is bound on bottom. It increases when x is greater than or equal to 0. It's decreasing when x is less than or equal to 0. It's symmetrical as an even function, and it does not have a maximum, but it does have a minimum. It has a minimum at 0, 0. All right, so taking a look at this video. So we first start off with basic reminders of what these things are. Domain is everything. It's all the list of all the possible x values. Range is all the list of all the possible y values. A function is when every input has exactly one output. So inputs cannot repeat, which we'll talk about down here. So indicate whether or not the following relations are functions, then find a domain and range. So the function in this case, is it a function? Sorry, so I meant to do that for domain. So domains are all a list of all the x values, which are these numbers. So we have 5, -1, 2, and -5. And each one of these is all different. And then -1, 7, and 2 are all of the ranges. Now, the ranges repeat. That's fine. Every domain can only have one range. So this domain has one range. There's no 2 5s. There's no 2 -5s. There's no 2 2s. There's no 2 -1s. So this is a function. Now, this one's not a function. The reason why is because these -2s repeat. So this domain of -2 has two different ranges. So -2, 4, and 5. So it has a range of 4 and a range of 7. So therefore, this is not a function. 4, 8, -1, and 7. Now, if I was taking my time, I probably would put them in order. But I'm not going to right now. So graphically, a function must have only... So it must pass the vertical line test, meaning that every domain has only one range. So this one is a function. The domain, and the domain will be 1, 2, 3, 4, 5, and 6. 1, 2, 5, and 6. The range would be the heights of all these points, which would be 1, 2, 3, 4, 5, -2, 0, and 1. Okay, this is a function because it does pass the vertical line test. There's no two dots that are on top of each other. This one is not a function because these two dots are on top of each other. So the domain of 1 has two different ranges. It has 1 as a range and 1, 2, 3, 4, 5 as a range. This one is also not a function. It does not pass the vertical line test. If you put a vertical line anywhere on the graph, it should never hit the graph twice. So that's not. So the domain in this case would be anything that's greater than or equal to 0, and the range would be all real numbers, but it's not a function. This domain would be all real numbers, and okay, so it'd be easier if I just write all real numbers right here. And the range in this case is everything that's greater than or equal to 0. This one is a function. This is actually the parent function of a square, of a quadratic. So this one is not a function. Domain is everything in between this number and this number. So what is that? 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm going to assume it's the same on both sides. So from -9 to +9, but also including, sorry, let me put brackets. From -9 to +9, and the range, I'm just going to, without counting, just assume it's 9, -9 again. I'm assuming it's a circle with a center and the 0, so that would also be from -9 to +9. Not a function, though. So this is a function. This is a sine function, to be more exact, without transformation. The domain in this case is all real numbers, and the range is anything from -1 to +1. Once again, not a function. If you draw a line right here, you're going to hit the flower-looking shape, which is in polar, which we'll do later in the year. This is not a function. The domain is everything from here to here using brackets, and the range will be also here to here using brackets because everything in between is connected. All right, so I would do the same thing for these questions. So using your graphing calculator, the first couple are fairly easy. I don't really need a calculator. It's squared. I know it's -2. So I know the function is going to look like this. So the domain is going to be all real numbers. And the range, if you put it into the calculator, is everything from, so the range domain is all real numbers. And the range in this case is everything from -2 and above. So cubic function, so you know cubic functions look like this, but it's also got a vertex that's here. So it looks like that. So this is, oh, I'm sorry, I did cubic root function. Let me try that again. So it's going to look like this. So the domain is going to be all real numbers, and the range is also going to be all real numbers. Number 3, absolute value. No, it's moved 3 right and 5 up. So 3 right, 5 up. It's going to look something like this. It has a domain of all real numbers. And it's got a range that's everything that's above 5, but also including. So sine function with an amplitude of 2, sine is going to look like this. Let me try that again because that looks more like a cubic function. Cubic roots function, so it's going to look like this. And it's going to start here, and it's going to go to a height of 2 right there. So the domain is going to be all real numbers because you know it's going infinitely left and right, and the range is going to go anywhere from -2 to +2, and also including both of them. Square root function's gonna, let's see, it's going 3 left, so it's going to be like this. So the domain is going to be x is greater than or equal to -3, and the range is going to be y is greater than or equal to 0, everything above 0. Now, with the last one here, you got to put this in a calculator in parentheses, otherwise it's going to do it incorrectly. So what you have here is something that's, okay, this is going to be a crazy one to graph. Let me put that. All right, so this one's going to look kind of like this. It's going to go down, it's going to connect up, and then go like this. Now, not everything here is an answer, so you have an in-between right there. So this domain is everything except for, so it's going to be all real numbers, except x cannot be, it cannot, I'm running out of room here, -1 and 1. And we'll talk about that in the next slide. And the range goes up and down infinitely, so it's all real numbers. Okay, so 12 most basic functions are defined for all real numbers. The domain is anything from negative infinity to positive infinity. And there are three functions where that does not occur. So that's log functions, then we have square root functions, and also rational functions. Because you can put certain x values into the equation and it's going to be undefined. Whereas all the other functions that we talked about, you can put in any value for the input and you'll always get an output. These functions have limitations. And so square root function, in this case, the domain for this question. So if you were going to set this equal to 0, so that becomes x equals -3. So in this case, the domain has to be from -3 towards infinity. And it does include -3. There is a reason for why this is because square root functions, in this case, have no negative. Okay, which basically tells us that x must always be greater than or equal to 0. So whenever you do a square root, you're never going to get a negative as an answer. That's the reason why we're setting it to greater than or equal to 0. So greater than or equal to -3. So now the rational function over here, you can never divide something by 0. So it's always going to have a vertical asymptote because you can never be dividing anything by 0. So I'm going to take this x squared minus 1, set it equal to 0, and solve it. And I end up getting x equals both positive and -1. So because the denominator cannot be 0. So one of these is actually going to be a whole, and the other one's going to be an asymptote, like I showed you on the last one. And I am going to stop right there. All right. Thanks again for watching, and I'll continue doing questions like these in the next one, in the next video. Have a great day.